This is our final project for CS271. For this project, Keegan, Tao, and myself did the gymnasium taxi simulation problem with reinforcement learning. For this project, our goal was to solve the gymnasium taxi simulation problem using reinforcement learning, as I said. Specifically, we were using Q-learning to train an agent to perform pickups and drop-offs of passengers to and from their desired locations using the Q-learning equation that we learned throughout the course of this class. This entailed finding essentially the combination of values for the following parameters that minimize the time to convergence. That was the learning rate, which controlled how fast we updated our Q values, the discount factor, which essentially impacts how much an agent values the future versus, other aspects of the equation, the convergence rate, which is the condition for the training to conclude. And then we also looked at epsilon decay, which incorporating this in order to emphasize exploration early in the training process while emphasizing exploitation later on in the training process. In terms of the environment, just to describe the taxi simulation problem, essentially it's a space of finite size, size 500, given 25 taxi positions, 5 passenger locations, and 4 destination locations. And essentially the job of the taxi is to go to a passenger, pick them up, and take them to their desired destination. The action space for the taxi is to either move up, down, right, or left, pick up a passenger or drop off a passenger. And then the reward mechanisms for this problem are +20 for delivering a passenger, -10 for executing a pickup or drop off action illegally, and -1 per any other step around the grid. It is important to note for this environment, the stochastic nature of this environment. It is an important thing to keep in mind just when looking for an optimal set of parameters for this problem, that even with multiple trials and multiple different random seedings, the solution is still impacted by the stochastic nature of the environment and its variables, like e.g. where the passenger is, where the taxi begins, what destination the passenger wants to go to, etc. In terms of the solution to this problem, ultimately we found that the following values of our parameters yielded the fastest convergence: a learning rate of 0.9, a discount factor of 0.93, and a convergence rate of 10 to the -6. We then found that an epsilon decay between 0.995 and 0.998 yielded dramatic improvements in the average final reward while maintaining and even improving convergence conditions. These findings and our path to them can be found in the following visualizations. So this was a simple baseline run, which was just full exploration. As you can see, this is not the type of taxi driver that you might want. So this is a baseline to kind of compare what we're looking for in terms of how much we want to improve this. And this was the chart of that, as you can see, not very useful. Moving down, we did have an improved run, however, down the line. As you can see, the taxi is making moves, maybe not picking up the passenger when we would want, maybe not necessarily taking them to their desired location, but it is an improved run, and as we can see, the chart does show some improvement here. However, our best run was when essentially the taxi went straight to the passenger and took them straight to their destination. As you can see, this was by far our best plot, by far our best, with the parameters as we already discussed, by far our best run. So that was the solution there. In terms of looking forward and potential future extensions for this possible run, overall, while this environment may seem trivial on its surface, upon further inspection, you can see that it is a scaled down in many ways version of just point A to B automation, which could have many possible applications in automated package delivery, autonomous car services, navigation optimization, etc., etc., etc. And so you can see that this is a very impactful project. It allowed us to learn a lot about Q-learning, a lot about epsilon decay, parameter tuning, etc., etc. And you can read all about it more in our write-up.